Welcome to our first lecture for Module 1 on Introduction to Deep Learning. In this module, I'll be going over the basics that we need in order to understand what deep learning is and how deep learning models work. In this lecture, I'll be covering the larger context around deep learning, which are the fields of AI and machine learning, and discuss what it was about deep learning that allowed it to be so revolutionary for the field of artificial intelligence. Before talking about artificial intelligence, I'd like to discuss what we mean by the word intelligence. You might be thinking about the common use of the word, which is someone being quick-witted or having clever things to say. But I'd like to focus on a more general definition of intelligence, which is the ability to process information in order to make predictions and decisions. When I say process information, what I mean is the ability to extract useful structure or interpretations from any sort of input. For example, let's say you're in a forest, and when the light rays from the forest scene hits your retinas, it requires intelligent processing to recognize that there is a tiger in the scene, and to choose your future actions accordingly. So why does it require so much intelligent processing to recognize a tiger in a forest? Well, recognizing things requires a huge amount of information processing. And so, what do I mean by information processing? Well, there's a mathematically precise definition of what information means and what it means to transfer information between two entities. And this is from information theory, and it's called Shannon's mutual information. But because this is a course on deep learning and not a course on information theory, I'm not going to go into the math of information theory. I'm just going to show you this equation to communicate that there is a precise definition for the concept of information processing. And so the fact that there is a mathematical concept of information is what I want you to understand from this. However, I would like you to understand that there is an intuition behind this mathematical definition, and that is that information is about narrowing the space of possibilities. So let's look at it for a simple example. Let's say you have a grayscale image. Each pixel then is represented by a number usually between 0 and 255, where 0 is black, which means no color, and 255 is white for full intensity. And anything between 0 and 255 is a shade of gray, which is like shown in this picture. So let's imagine we live in a world of 3x3 grayscale images, and that all variations of these 3x3 images are possible. So every square can take on 256 values, which are the different intensities of gray in grayscale. So how many possible different 3x3 images can there be? To calculate this, we take all the possibilities for one square, which is 256 possibilities, represent all the different intensities of gray. And to get all the possibilities for two squares, we multiply the possibility for one square times all the possibilities for the second square, which is 256 times 256. And we have to continue doing this, so we have to multiply 256 times 256 times 256 all the way up to 9 times to get all the possibilities that all 9 squares can have altogether. And this comes out to a number equal to 4.7 times 10 to the 21st power. So this number with 21 zeros at the end is how many possible images we could have if we lived in a world where all we could see were 3x3 grayscale patches. That's a lot to process already, but that's not the world we live in. We live in a world of images that consists of more than just 3x3 grayscale squares. So the number that represents the possible images that we could process is a number with at least millions of zeros behind it. It's not a million possibilities, and that would be a very small world, relatively. The possibilities are a number with at least a million zeros. And this is just for still images. And we process moving images and much, much more. We're carving out from that space of possibilities that is a number at least with millions of zeros behind it. So that's what I mean by information processing. I'd said that intelligence was processing information in order to make predictions and decisions. Actually, making predictions and decisions is again information processing. Predictions are narrowing the space of possibilities to what's likely to happen out of the space of all things that could happen. You make a prediction by narrowing from a larger space of all the things that could possibly happen in the future to the small space of things that are likely to happen based on your past and present experiences and knowledge. Finally, a decision of how to act requires knowing your goals. Here with a tiger, let's assume your ultimate goal is survival. Again, this requires predicting which of our possible future scenarios is most likely related to survival. More generally, you might widen the question of what your goals are, but in the end, most of us want to stay alive and experience fulfillment in life. So again, it takes information processing to carve out what scenarios are most likely to lead to staying alive and being fulfilled from all the scenarios that are possible. In all these cases, no matter what level of description you're using for your space of possibilities, we're undergoing this process of information processing, which is carving out the smaller relevant possibility space from a very large space of possibilities. This is what I'm talking about when I say intelligence is information processing for predictions and decisions.